organizing secretary.
Good morning, Anantharaman sir.
Admin.
Sir, Anantharaman sir.
Anantharaman, good morning. Good morning.
Anantharaman
How
sir,
are you?
good morning.
Morning to everybody.
Apsiguda, how
After a
is
long
it?
time. After a long time.
Apsiguda, how is it?
Oh, very fine. No
No
problem.
problem, is there?
No
No,
COVID.
it's not like that.
Gautam sir, ready, Gautam sir?
Okay.
Okay.
Yeah, okay, sir.
Please mute all and you will release all of us. Only 3 of us. To audio. I request all of the resource persons, participants who are in the video can stop their video and you can also mute their audio so that resource persons will be, only the resource person can be viewed in the screen.
Apsiguda, how is it?
Oh, very fine. No problem.
No problem, is there?
Charles, mute all, mute all, mute all.
Gautam sir, இப்போ நீங்க unmute பண்ணிட்டு நீங்க பேசுங்க.
Good morning, dear participants. We are on the last day and last session of the webinar, and it completely involves the application part of our geological science. And you can find a very senior person sitting in front of our camera, Shri.S.Kannan, who is the Chief Geology in Engineering Geology and Geotechnical Division, Corporate Office of National Hydroelectric Power Corporation Limited, Faridabad. He has retired from that NHPC, and his topic is on engineering geological studies for large civil engineering projects. So the webinar is as planned, as we have introduced the geological evolution of Tamil Nadu, and it ends with the application part of geology. So that's what we are our plan. And Sri Kannan sir is a very experienced geoscientist in the field of geology, earth sciences. He has put his experience more 35 years in the field. He has completed his MSc from Bangalore University, both BSc and MSc from Bangalore University. And he was briefly working in government of Tamil Nadu PW department, in groundwater department. So after getting job in NHPC, he shifted to NHPC. Before that, he was working as a geologist hydrogeologist in PWD government of Tamil Nadu. He joined the NHPC as a field geologist, and he has worked in various capacities. And he has, in his service of 35 years, he has served so many projects. He has worked in so many projects and created many geotechnical structures for the country, which is more important for the development of the country's economy, and especially in irrigation project and civil engineering projects. That Shri Kannan sir is not a ideal person sitting at home after this retirement. He was very busy than the NHPC after the retirement, because he was a consultant in the GMR consultants. So he was a vice president and ex-associate in GMR consultancy. And he's also an advisor for the government of Karnataka in Bangalore. Some geological clarifications are requested to him, and he is clarifying that. He's an advisor for the government also. And in the field of engineering geology, he has done so many surveys from the base, from the beginning to the end, and after the end, it has maintenance is involved. His expertise is involved. He has created and he has completed so many hydroelectric projects in very challenging terrains. That is more important. Conducting a electric project in a safety terrain is not that much important. He has surveyed detailed from the beginning. We can say that from the point A to Z he is working, and he's still having his He's giving his expertise after his retirement also. The work he done is involves search, evaluation of site for project structures, dam, water conductor system, channel, tunnel, shaft, powerhouse, evaluation of reservoir competency, appraisal of infrastructure, including roads, rails, bridges, and colonies, etc. You can say so many things. All the civil engineering are put together by a geoscientist, and he has excellently carried out this work. And I can read out his biodata. So many pages are there. Shri.Kannan sir, I'll stop here of introducing you, and I request you to complete the presentation, because our principal will be joining shortly. So we have to conduct a brief valediction function also after your talk. I request you to take over the section, sir. Sir, please.
Thank you, Gautam sir. Dear all, very good morning. I welcome all of you for this webinar session. First of all, I thank the principal, Presidency College, Geology Department, and especially Dr. Gautam for giving me an opportunity to share some of my professional experience with you all. And here I would like to thank Mr. Charles for giving wonderful, seamless connectivity and management of the overall session. And I welcome the students, the scholars, the other professionals who have enlightened us on various subjects of geology. And with this, I will go. A small brief introduction about myself has been already given by Dr. Gautam. So I joined GMR Energy from NHPC after resigning from NHPC, in fact, and joined GMR. And from there, I retired as Associate Vice President, worked in mostly in Himalayas. I have widely traveled across Himalayas for the hydroelectric project locations, right from J&K in the west and to the Arunachal Pradesh in the east, including Nepal, Bhutan. I mean, there is no sector in Himalayas which I have left. I have traveled extensively for the project from the concept to commissioning. Initially for a new project, selection of site, and then ongoing preparation of detailed projects reports, and then going for construction. And some of the project after post-construction, likewise, the geology, varied geology, the young mountains of Himalayas. It is really a challenging environment, and it has given me a very good experience. So I thought I will share with you all. This lecture focuses on the engineering geological studies for large civil engineering structures, because it's not
Kannan sir,
project is not the
Kannan sir, yes, please share your presentation and then just start. Share your presentation slides. And I'm sorry for that. I have got all your CV with me, but I just want to brief. That's what I didn't say all these things and all. But you told everything. Thank you so much, and I'm very sorry.
Yeah. Now my screen is seen.
No, sir. Not
Hello?
Yet. Not yet, sir.
Not yet. Okay.
Please share the screen.
Yeah, I'll share. Now it is visible?
Yes, sir. Yes, sir. Yes, sir. Slideshow,
Yeah.
sir. Please make it a slideshow.
So this lecture is about engineering geological studies for large civil engineering structures. Wherever possible, I will share my
Kannan sir.
site.
Kannan sir.
Yes, sir.
You make it as a slideshow.
Yeah. Yeah, fine.
Thank you, sir. Thank you so much.
Sir, basically, engineering geology is a branch of geology, as you all know. In other words, it is the application of geological processes and principles for the execution of civil structures. We all know that there are many branches of geology. I will come to it in course of my lecture. Similarly, civil structures also. This may be as small as a small culvert or a bridge or a large building, multi-story buildings, tunnels, dams, irrigation canals, etc. These all civil structures have got some unique advantages and disadvantages as far as site condition is concerned. In good olden days, even in 1930s and 1940s, people did not give much attention to the importance of geology that for construction of projects. This led to wide-scale failures and cost and time overrun. That is the biggest problem the engineers faced. And moreover, nowadays we are moving to more complex geological environment. The projects are located in a very environmentally sensitive, geologically complex areas where a proper investigation, proper studies, and the application of geological setup and all these things led to the development and more importance for engineering geology. Therefore, people felt the need for proper geological investigation. This led to the development. Now we'll go to my presentation one by one. See here, I told you there are different, there are many branches in the geology like mineralogy, petrology, structural geology, remote sensing, geophysics, stratigraphy, paleontology and all. Likewise, the studies for engineering importance, like we have to deal with rock and soil, and we have to do the survey of that area. We have to do the engineering design for that structure. We have to adopt a proper drilling and blasting technology, and also the evolving tunneling technology. This is now every time we are going for some new technology based on our experiences. So next is the various engineering domains. If I discuss, there are buildings. First of all, buildings normally nobody consults a geologist, but they definitely do a soil testing. Or if there is a rock, then they adopt certain techniques to remove the rock and then do the. So that if it is a multi-story building, definitely you have to consult a geologist. That's what I feel. And then the bridge for bridge abutments, and then a bridge foundation, the geological investigation needs to be done. Then the major structures, if you take up, it is a dam, it may be a small dam. Any dam which is more than 15 meters in height, we call it as a large dam. Then underground structures, it may be a small tunnel, or it may be a big cavern, powerhouse cavern. Nowadays, oil storage caverns are also made. A lot of work is now going on underground. Recently, we are able to connect to our border areas through underground tunnels. So we all know this. And another big problem which we are facing, because we are working in Himalayas or remote areas, there is slope stabilization, and then shoreline, as you know, then the highways. So all these things, these are the various engineering domains we have, as a geologist, we have to deal with. Then I will go to the geological principles in engineering geology. Who is an engineering geologist? The engineering geologist plays a pivotal role right from the inception to the commissioning, post-commissioning of civil engineering process. This is what we should take into consideration. The engineering geologist has got a role to play from the beginning to the commissioning, and also during post-commissioning time. So engineering geologists should be aware. So therefore, what are the things engineering geologist should do? So he should be aware of the relevant approaches for defining a subsurface objective, because everything is not visible on the surface. Certain things are inside. So only a geologist, he should have a proper objective prior to the initial site reconnaissance, so that the subsurface site investigation can be designed to yield sufficient and meaningful information. That is what a designer, as an engineer, he wants from a geologist. So then the objective would be collection. So with this in background, we should have a proper objective. The objective is the collection and presentation of geological data, defining general geological environment and rock mass character. What is the rock is available? What is the type of soil? What is the type of slope? All these characteristics of the site, and basically for the design engineer and for other agencies like seismic award evaluation, construction material, construction personnel. So these are the things we have to bear in mind. Then with this background, then you should have an output. Output also should be lucid and it should be easily understandable. The presentation of geological data is as important as the collection of data itself. If you don't able to present it in a proper format, understandable manner, then the user will be perturbed. It should be as graphical as possible. Same way, unnecessary explanation should be avoided. This is the most important. We may have, we should have a historical, social, cultural, or any other such feature relevant to the project. But unnecessary explanation should be avoided. That will confuse the user. So it is fully recognized that specific investigation programs and studies for individual projects. See, because each project is unique. You cannot apply a principle which you applied in a previous project for this project. So each project has to be, it is unique and you have to properly, realistically, it should be studied. And it will vary widely according to site condition, type of structure, hazard classification, design phase, etc. So therefore, effort should be to stick to standard practices as far as possible. So for an engineering geologist, the term geological mapping always encompasses special attention to the collection of discriminant data. Here I will just try to explain further, because the engineering geological map is slightly improved than a normal geological map. In a normal geological map, we'll have lithology. We may have the attitude of bed, that is the foliation or bedding or like that. Then some lineaments and other topographical features we will have. But in an engineering geological map, we should have the discontinuity data, the fault zones, the shear zones, and then the slide zones, all the geomorphology, the condition of the geomorphological processes and the underlying geological structures. So all these things should be added to the geological map. Then it becomes an engineering geological map. So the role of engineering geology in a nutshell, I will say proper selection of site. So this I will explain with a photograph when we proceed further. Then discover the geological facts, advice in detailed design. So with these two aspects, we will go for a advice, and then mapping and support advice during construction. During construction also, because this is up to design, and then during construction we have to give an advice. But continuously we should do the mapping, and then geotechnical monitoring during post-construction. When once project is commissioned, then during the running of the project, there may be some geotechnical, geological problems that we have to be monitored. Then this above all, to minimize geological risk during construction through pragmatic investigation practices. That is what we are going to discuss today. So now investigations. Investigation, most important is data collection with the help of geological and geotechnical investigations. So we will go each one by one in the course of this thing. So there are different stages of development of whether any engineering project, even if you are constructing a building, first you have to do the excavation and then foundation and then like that. But before that, you have to see the site, whether it is a suitable site. So for a large engineering project, we have a feasibility stage, then DPR stage, then construction stage, then post-construction stage. So we'll go one by one. I am not going, because of time constraint, I am not going to explain in detail about what is given, because these slides are being shared. You can go through it leisurely. So the stages of development here, the pre-feasibility stage, investigation is done. Then feasibility stage investigation done. Then DPR stage investigation is done. and then construction stage monitoring and data collection and advice support. This is done during the construction phase. Then we are going the pre-feasibility stage. Normally we rely on the old literatures because we cannot do, there will not be budget for a big investment. So now, well, first of all, we have to find out whether the project is feasible or not. So we go through old reports, literature, regional geology. Regional geology is available from Geological Survey of India. Then some aerial photographs are procured from Survey of India. Satellite imageries or NRSA. So they are Hyderabad. They are able to provide us this. Then we do only a reconnaissance geological mapping. See, probably in 1:50,000 scale or 1:25,000 scale. This mapping is done. Then a small report, a brief report on the geological aspects for the pre-feasibility stage. Then during feasibility stage, we go for a regional geological studies. See, regional geology plays a very important role for an engineering geologist should be well versed with the regional geological setup. Then only he will be able to identify what is the right type of rock, and then what is the characteristics of the rock, what is the mineral constituents in the rock. So all these things very important. So now, why I am stressing this is because when once a person appeared for an interview and I was in the interview board, and I asked him from where you are coming. He said, I am coming from Bhopal. I asked him simple question, from Bhopal to Delhi you have traveled. Just tell me what is the geological formations you came across while traveling in the train all through. What is your observation? So, but unfortunately he was not aware of this thing, even the geology. So what I find is that is the young geologist. First of all, there was a beautiful lecture on the geology of Chennai in the previous session, and the persons and the presidency college students, they are very now well aware of what is the geology around Chennai. Like that, our surroundings, observation is very important, and at the same time, the literature knowledge is also very important. Then we go for a topographical survey, geological mapping, and then the geophysical survey, because everywhere we cannot have boreholes. Some of the subsurface inferences are made through geophysical surveys, then few boreholes only. So depending upon budget, because every stage of investigation involves some expenditure. Then seismicity, this you get from IMD, Indian Meteorological Department, they will be able to give you. So from that you have to infer and what is the status of your project. Then DPR project, that is DPR stage. See, we have to prepare a bankable DPR. Bankable DPR is a DPR which contains very detailed information, whether on the feasibility of the project, on the economic viability of the project, and the saleable electricity should be saleable. All the the project should be able to give some revenue, and then whatever the loan you take from the bank, it should be repaid. So for that, a detailed that only if there is a revenue you'll be able to repay, and for that your structure should be safe. It should be economically feasible. So for that, what we do is a detailed topographical survey, a detailed geological mapping, subsurface drilling, underground drifting. A drift is a small hole, tunnel, which is about 2 meter by 1.5 meter in the dimension, and then one person can go inside and then inspect it. Normally, a geologist has to go and then he has to record all the whatever is observed. Then small trenches and pits in the slopes you can make, and then we go for a geophysical survey. This is a cost-effective. Geophysical survey is cost-effective, whereas the drilling, drifting, this involves more money. And if you're drilling, you get only point information. But with 2-3 drillings and a geophysical survey along that boreholes, then you will be able to connect the gaps. Then we collect soil, rock pieces, and then do testings, both in the laboratory as well as some tests or in situ. Then petrographic studies to know the mineral constituents, some layers, and then also for construction materials, we do petrography studies to know the quartz percentage and other things. then a seismotectonic appraisal. Seismotectonic appraisal is most important because nowadays many projects are made in a seismically active region. You have to select what is the type of dam and how large the dam. Whether nowadays there is a lot of opposition for large dams. Now people want to go for a small dams. And if a site is in cascade, if you make instead of one big project, you make some 4 or 5 projects. But it has got its own disadvantages. Somewhere it is advantages because this operation of the 4 projects in one river in 10-20 kilometers, so that a tandem operation has to be up. So if you have one big project, there is a flooding problem, and then if it is seismically active region, then there is a lot of concerns made by these environmentalists. So then the reservoir, the DPR investigation continues. We have to do the reservoir competency studies, whether there are escape routes for the reservoir, whether the reservoir is tight or not, and then permeability tests are done in the boreholes. Then construction material. So this is the most important aspect, construction material. I'll come in detail with more detail. I have prepared this thing. Then we have testing and identification of quarry sites, preparation of detailed project. So with all this data, with all the results of all this data are compiled, and a detailed project report is prepared. So now I'll go to the next slide. So what are the laboratory investigations? So we go for a inaxial compressive strength of the rock, then triaxial compressive strength, shear test, tensile strength, shear wave velocity, specific gravity, porosity. So these are all some of this thing. And then grain size analysis. These are the laboratory investigations which I'm in situ dry density, moisture. This is all just for information. I'm telling these are the standard tests which are given in the Bureau of Indian Standards. So you have to do. First of all, you collect the samples. While doing the mapping, you collect the samples. If there is any variation in the lithology, each lithological unit has to be tested for this thing. Then in situ test, you do it underground, or we do it in the surface also. So the direct shear test and then deformation modulus. So these are some of the techniques which we adopt as per international standards. Then geophysical investigations, say for example, resistivity survey that is widely adopted. Then for groundwater, then earthmat design, we do geophysical resistivity survey for the electrical substations and all. Then seismic refraction survey, just generally to know the depth of bedrock. Seismic refraction survey is done by small holes are made, and then energy is generated by blasting, and then the travel and the wave, surface waves and P waves, that they travel some distance. So along that line of along that profile, you will know the depth of bedrock. We in this engineering projects, we use refraction survey, and for oil and other things, we go for a reflection survey. In the seismic, we do the seismic refraction, and also we can know the shear wave velocity of the rock. So these are some of the geophysical investigations, and it's widely used. Then we come to post-construction stage. Now the DPR is prepared, then we go for a post-construction stage. In the post-construction, when once the project is completed, then you have to see this is a large dam. There are slopes here. So there is a big reservoir behind this thing. Now here the slope has to be tight. But if there is any slope failures, then we have to be careful, and then we have to do the study and monitor these things, and then give the geologist has to give an advice. See, this slope is becoming unstable, and then we have to do this type of treatment, and or then in the engineering treatment it can always be given. So the same way, the reservoir stability, whether there is any leakage in the reservoir, whether there is an instability in the reservoir rim, whether the reservoir rim is safe, whether the water can be tight, that is the most important. And then siltation of the reservoir. In one of the previous session of Mr. Prabhakaran, somebody asked the question if the reservoir siltation, sedimentation. So how it can be? So now most of the Himalayan rivers carry a lot of silt. They mean you cannot imagine how much silt tons and tons of silt comes and occupies these reservoirs. What they do normally, it's an engineering solution is there. There are various solutions. Each solution cannot be, has to be unique, and it will be project specific. For example, in most of the dams, they have.
கேஷியருக்கு கொரோனா வந்துச்சான்
Hello.
அவர் கொல்லிமணம் அவரு
Hello. If it is a barrage, there is no problem. You open when there is a flood, you open the gate, all the gates, and then the water flushes the complete silt, and the reservoir becomes clear. Then you put the gate. Then it's in large dams. Then you keep the crest of the dam low as the bed level of the river or the reservoir, or maybe you can have under sluices. That is always a design solution. Under sluices are built so only to flush the silt load. And in some projects, say normally there is a diversion tunnel constructed during the construction of the dam, and then these diversion tunnels are kept even after. Only in some projects, I'm not telling it's a universal. In some projects, those diversion tunnels are used as a silt flushing tunnel. During flood, they put all the gates and then open only the diversion tunnel, and then some of the silt in the reservoir, it gets washed away through the diversion. So like that, there are solutions. This being practiced, and it's a perennial problem, and everywhere we are having this problem, and there's some unique solution has to be evolved. I am not telling the problem is totally solved. Then I'm not going in very detail because of time constraint. There are different scales by Bureau of Indian Standards. They say that a project should have this, in this scale we have to do the mapping, we have to do so for doing a geological mapping, you require a topographical map. The topographical map should be of this scale and all. I'm not going much detail. Then this is one of the drilling mission, which I wanted to show. This is the core sample. See, you have taken out the samples. So here again, there is a Bureau, Indian standard. This has been standardized. How the core should be collected, how it should be stored. See, you can see some markings are there. So the direction of, because every time a geologist cannot be there at the site. So when the drilling is going on, normally the driller and then some helpers, they have to arrange these things. So for that, there is a standard practice, and this standard practice is adopted everywhere. You can see each core is numbered, and then the direction of the drilling is. So whenever geologist comes, any geologist comes, he will be able to. It's a very valuable record because so much of money is being spent, some 10 to 20,000 rupees per meter. So you go for 50 meter, you can imagine what is the cost. If you are making about 10 to 15 boreholes for a small project, you can imagine how much cost is involved. So the preservation and presentation of this data is very important. It should be preserved till the completion, and also in some of the projects I have gone, the project is commissioned, everything is done, and there are some problems. Then I asked for the old course. These are the course. And then to infer, say what could have been the problem. So these things should be, geologists should ensure that these are all kept forever. So this is the record of the borehole data. See, you can see what is the lithology is given here, the depth is given here. Then the core recovery, what is the percentage of recovery in the borehole, that is graphically presented here. Then water loss is there, groundwater depth is there. So what type of casing has been used, whether casing has been used or not. Then a small observation by the geologist. And then most important thing is here, I think you can follow my cursor, the location of the project, the coordinate of the project, the elevation of the project, when it started, when it ended. So all these data should be properly preserved. Then that's I told you a small drift is made in for a hydro project here, a dam project. Here, one person can go. Is a geologist, engineering geologist, who goes just for him to go and observe what is the rock type inside and other things. So 2 meter by 1.5 meter width small tunnel is made. It's in a very crude manner it is done, and also full safety precaution is taken. So you can see some wooden supports are given somewhere, because if you totally support it, then you will not be able to see the rock what it is. So these are all recorded, graphically presented in a graph sheet. Each and every joint is recorded, each and every feature, if there is any folding or faulting, or there's a variation in grain size, there's a variation in the lithology. All these things are even shear zones, clay filled joints, open joints, all these things are recorded through this, maybe some 30 meter or 50 meter deep inside the hill where your project is located, the dam is located. So this is all very important aspects, because all these things are done before construction, and then the data is recorded, and then based on the data, you prepare your geological inference reports and other things, and then give it to a designer, and then finally designer is able to make a proper, safe, and then economically viable project. That is the most important aspect in this investigations. See, during pre-feasibility stage, what we do is, this is a river is flowing. You can follow my cursor, the river is flowing this way, and then we propose a dam here. We take the help of this satellite imagery. I mean, this is Google Earth. Basically, the Google Earth. We do it on satellite imagery also. And then intake site, the power house may be in underground here. This is in a hill ridge. You can see here in the hill ridge, the underground power house could be there, or near the river, you can have a surface power house by excavating this area. This also. So all these things are planned during the DPR stage, investigation stage. This is the geological map. So I told you the geological map, the lithology, the attitude of beds, different joints, what is that? So all these things will be there. In addition to that, this engineering geological map will contain where you have done boreholes, where you have done a small drift or tunnels, where you have done the geophysical survey. All these things are marked in one map, and by opening that map, you know complete investigation, what you have done for that project, what is the geology, everything. One is overlapped over the other, so that everything is seen in a nutshell. So this is the geological section. Of course, this is again for a hydro project, a dam project. See, this is the top of the dam. You can see this is the it's a sedimentary rock, sedimentary domain. So here you have a sandstone, and then you have a siltstone. These are the boreholes. This has one side, it has got a recovery, other side it has got an RQD. RQD is the percentage, I mean rock quality designation. So this is all graphically presented here in each borehole. And then you have tunnels, small tunnels, inspection tunnels, where we go inside and pick up these joints. And if there are any shear zones, other things, it's all marked here. So these are all the discontinuities we have seen observed in the area. So with the help of apparent dip, then we all the geological preparation of geological section geologists know about it. I will not go into that. So what is important is this borehole locations are given, the top of dam is given, and the road, this is the road. So this is how it is. So it should be as simple as possible. At the same time, it encompass all the details of your investigations, so that you can have, the design engineer will know how much stripping he has to do for founding his dam. So a lot of money is spent on this. We have to be very careful. So the analysis and interpretation, detailed study, I don't know how much time I'm having. I'm having another 20 minutes. I'll try to close it fast. Geological mapping is a basic thing, and I'm not going into detail, but I only told you as an engineering geologist, for a civil engineering structure, whether it is an irrigation structure or it is a multi-story commercial building structure, or you do a small geological map, or it is an hydroelectric project, river valley project, go for a basic geological map, incorporate all the engineering geological data also. That is the joints, the shear zones, if there is any fault, if any investigation has been done, and all those things are incorporated in the this thing. Then you go for studies of collect during the course of geological mapping. We have to collect the rock samples wherever the lithology changes, and then you do a macroscopic study, macroscopic study, and then this macroscopic study we normally get it done through laboratories. Geological Survey of India, different regions they have petrological labs, we can get it. Then we have to do the proper attitude measurements. Then we have to do a statistical analysis, mean, mode, median, and then we have to, these things are very important. So there are principles how to draft the geology. So the preparation of geological map and preparation of geology, which I have already shown. So now we are going for data analysis, again continued. These are all desk study. Desk study involves aerial photographs, regional geological, knowing a geological setup, regional structure, that is very important. Then river study, how the river morphology is there. So geomorphology has to be studied. Then the gradient of the river, if the river is more having gradient, then it will be more violent. Then deposits by river and terraces. The terraces you find along the river, maybe of different ranges. You will have, whenever you travel in some hilly areas, you will find along the river there are 2-3 levels of terraces. So each terrace has got a different age, and depending upon the age, if you see the constituents of that particular age of terraces will be different from the other terrace which is overlying it or underlying it. So these studies have to be made. This is a very detailed study is required for this, because the geotechnical characteristic of each material difference. If a particular terrace deposits of a particular domain, depending upon the velocity, the flooding and other things, the material varies, because river for that particular time the river carries a particular material. So these are things that should be studied, and then any major lineaments are there, then a thematic map and all this. I am not going very detailed. The time is short. You have to establish the order of superposition. We have to devise a proper legend, some surface investigation data. This I am not going much. Then stereographic projections are also made with the help of software. Nowadays, a lot of software are available. I'm going fast. Then geophysical survey, I told you where and why, what is the type of geophysical survey that a geologist has to decide, because geophysical survey is cost effective. You cannot have more number of drillings. We can reduce with this thing, using geophysical survey, we can reduce the cost of drilling. Then small pits and trenches, these are cost effective methods, but you cannot go for a pit more than 5 meter or 3 meter or 5 meter, because again logistic problems will be there. So then permeability tests are conducted. So these are the, then with is all this investigation adequate or not, that is again is a question mark, because any investigation will not be totally safe and complete. So now somewhere you have to put a full stop. So this is not going much into the interpreted geological map of the project is prepared. Then an outcrop map of the project. See, these are the design requirement. Then supporting studies, this is most important. You have to go to the level of geological support. The seismotectonic site-specific seismic design parameters. Here I want to stress certain things. Because seismotectonic study is most important. Many projects are located nowadays are being planned in a seismically active region like Himalayas, where the seismic zone, as per seismic zonation map, it falls in zone 5, is high seismic zone. So a lot of problems, social problem, environmental problem. People are saying that it's a seismic hazard area, you should not go. But we have to have the project. We cannot. We have to do the nation building. So there is a solution. There we can have a safe for this thing. The only thing is you have to adopt a proper design parameter. For that, we do a site-specific study. Site-specific study is done by Roorkee University Earthquake Department of Earthquake Engineering is there. CWRS Pune is there. We get this conducted based on, they also do based on the major geological structure like a main boundary fault, where these earthquake, historical earthquakes are there, it has happened, some analysis are made. So we'll not go much detail, but what I am just stressing is there is a design solution. Even Mr. Prabhakaran in his previous session told that the Kalpang project, Andaman, I had also been there. I did the foundation mapping there. And that project withstood the tsunami. After tsunami, nothing happened because that Andaman project was constructed before tsunami, and after this a 50-meter high dam, nothing happened. The project is still active, producing electricity. So there are different institutes for rock mechanics, soil mechanics, system technology, like that. Then we are going for so another important aspect is construction material, whether it is a building or a irrigation project or an hydro project. Construction material is very important. So what they rely on geologists. They ask you, what is the requirement of material? What is the type of dam? It's a rockfill dam, then you require rockfill material. If it is a concrete dam, you need aggregates. So from where you will bring it? So you have to do a field investigation. You have to adopt excavation methodology. You have to have a preferred location, because every location nowadays either they fall in a reserve forest area or in the river. There are a lot of environmental problem is there. Local problem is there. Now we know we are facing sand problem for a small house construction. So then there is a sampling, testing, reporting, and all these things. Then a detailed quarry map is prepared. I'm going very fast. Then this is during construction stage, we have to do logging, mapping, rock mass classification you have to do. And then based on these data, we have to go for a support. What type of support we have to do? This is a daily basis, daily work of a geologist to do all these things. Then you have to study and advise for groundwater. There may be a groundwater flow, which I'll show you one of the photographs. I'm going fast. Then post-construction, you have to go for a dam safety, whether the dam is safe. Then we have to go for a reservoir competency that I already discussed, the erosion and abutment ability, that seismic activity, Fanny. In one of the project, big project, we installed micro earthquake stations, only about 6 stations in 25-kilometer radius, only to record any seismic activity as low as even 2.5 scale. So then periodic inspection of dams, tunnels, bridges, abutments, river erosion. So these are for large engineering projects. These are all the geologist has to do. I'm showing a small model. This is I could have shown a photograph of a big project, but I thought this one is my favorite this model. We got it done to a model maker. This is about a model of an hydroelectric project. You see there is a reservoir, there is a dam, and this is the diversion tunnel. Before for the foundation, we have to divert. This is one of the branch of this thing, Brahmaputra River. So here, this is the diversion tunnel. Then you have the power tunnels here. Then a powerhouse is constructed here. Then surging chamber is here. This is the dam. So you can visualize. See, these are the intakes for the tunnels. These are the intakes of the tunnels. So that is how it is. Then this is this photograph I am showing. So a selection of a proper site. So if you have to have a project, you see there's a rock is available here. Then here this side you are having overburden. From here again there is a overburden. River is flowing this way. Then you can have a dam here or here or here or 5 kilometers away from here. Or so all these things have to be studied. I told you, with a combination of studies, with aerial desk study and then site study, and then doing some investigations, because we have to have a project where it is feasible and the rock is available for your foundation. If rock is not available, you should have a rockfill material, or without rock also we can have a project. Then you have to type of dam you have to finalize. So for that type of dam, you have to have the material, what type of dam you are doing. So here we can, to know the bedrock, we do some boreholes. Line drilling is done from here to here. Then some from here to here also we can do some line drilling. and then you can have some geophysical profiles we can lay on these banks, and then find out what is the depth of rock, and then whether we can have the excavation of that overburden. See, this is the overburden. Here rock is there. Here you can abut the dam, but here the foundation you should have safe depth, not very deep, because if it is more deep, then more excavation, more cost. So all these things are decided based on site. Then this is one of the drilling machine in a river, and then you see you have in somewhere Mr. Prabhakaran showed in a river barge a hole. Here I am showing an inclined hole. Here sometimes you cannot go inside near the river. This is very ferocious river. Then we go for a inclined drilling and then infer the data. See, this is a road tunnel we made, because just I'll show you, it's a portal in inlet side, how safely they have done, and then doing drilling for putting rock bolts, and then you can see wire mesh is there, and then this whole surface is shotcreted so that people walking here, there is no loose fall. So this protection, when geologist has to keep it in mind, and they have to advise how it should be done. Then inside the tunnel, the rib erection is going on. So a lot of slabs are falling. So this area needs to be protected. So they are going for a rib erection. So nowadays we are going for a TBM, tunnel boring machine. The metro projects are done through tunnel boring machines. You have a cutter head here, and then you have see here in normal drilling and blasting technology. In this one, you have to have a separate every time. One team will go, they will do the drilling. The other team will go, they will put the blasting material, the blast it. Then the third team will go, and then this will be done. The time they will go for scaling, and then mucking has to be done separately. So this is the drilling and blasting methodology adopted normally in the tunnel. But nowadays, this TBM, tunnel boring machine, this contains everything. It has got a conveyor belt. The cutter head will go ahead, and then the muck will be flown through the conveyor belt, and then you will have support the shotcreting. Immediately it will do the shotcreting, and so everything is. But whether this TBM can be adopted for all the projects, no, it is not. You cannot say that way, because in one of the project we are stuck up with the TBM, and then the TBM has to be abandoned because it cannot go back. It can go only forward. It cannot be brought back. So we had to, with the TBM stuck with a sand deposit inside, and then it was a paleo channel. Then ultimately that was stuck up, and then rerouting was done for the tunnel. So this is a disadvantage also. Somewhere we have to, a geologist has to advise whether we can go for a tunnel boring machine, or you got to go for a NATM method or a new Austrian tunneling technology. All these things have to be decided. See, there are a lot of challenges. So the challenges are for the development of any project. It could be a regulatory problem is also one of the challenges. It is we should not say that way, because regulatory is for the human this thing only. It has got a human concern. That's why there are a lot of regulatory this thing. Then societal problem is nowadays it's cropping up. We know Kudangulam, or it is any other. This is societal problems that logistic due to remoteness. Here I want to see the projects nowadays. The new projects are coming. They are in remote areas. So the logistic is very difficult. The getting right talent for remote localities. Here I would like to tell now the young geologists, the projects cannot be made in your backyard. The projects will be in a very remote area. There will be no basic facilities, where I have lived 6 years, 7 years. There were no base, even electricity was not there. The telephone connectivity was not there. So I lived there with for more than 6 years. Mr. Prabhakaran also was my colleague there. So what we have to do, we have to take the national development, we have to take it as a challenge, and then we should go work for the nation building. We should go, because we are used to nowadays people are going for a AC room and then sitting in front of a desktop and then work. So it is not like that. Making a project is not like that. We have to see that Dr. Abdul Kalam's vision come true. For that, we have to work for the nation building. And this is my advice to all young engineers, talented engineers. Go for such a don't say no to go and work for remote areas. Of course, initially there is a problem which I have also faced. Everybody will face it. We want very comfortable this thing, but still we will work. Then the commercial aspects. I'm not going very detailed. Because the project is to be viable. That is the main commercial aspect. That is a challenge again. Then technical challenges, it can be engineering challenge, or it may be geological or hydrological or environmental. So these are all the challenges. Then you see, this is one of the challenge which I want to show. There is a huge rock fall. It is more than 250 meters. If you get such a thing in our project area, it is a big problem. It's economically you will be in soup. And then you see the road connectivity. There is a slide. This is a road to Badrinath. This photograph was taken by me when we were approaching, and then suddenly the slide took place, and then we had to return back. So like that, the days are wasted, the time is wasted, money is wasted. With these are all natural this thing, and this is the loose material. This keep on moving in the Himalayas. This is a normal site. Most of our geologists, seniors, they have worked in such areas. And then inside tunnels, see, you have a groundwater problem. There is a seepage here. There is a seepage here. There is a continuous what a geologist has to do, whether it is a landslide area. What the geologist has to do is he has to do the mapping, the extent of the slide, the crown, and then the toe, and then what is the material involved in this slide. So this much data, if a geologist is able to produce, that will give solution. Solution can be devised. It could be a contour groundwater drainage problem, or a toe wall problem, how to found out. So these are basically the geology. Here also, that you have to know how much quantity of water is coming, whether the groundwater coming is it has got a perennial source, or it is only a perished groundwater, flows for 2-3 days and then it subsides. So all these things need to be studied by a geologist and then advise the civil engineer, project engineers. So there is a collapse inside the tunnel, and the geologist has to see what is the type of material it is coming, from where it is coming, how. So these are the studies we have to make. There's a irrigation channel is going on. You can see a cavity formation. See, actually this is the road. You can see a man is standing here, and then this is the slab, and below which there a cavity is formed here, and the slope also collapsed. So this is post-construction problem. So then I found that it is I went to the site and found that it's a limestone country, and there is a cavernous, could be one of the reasons. See, this is just a challenge. The big river like Brahmaputra. At this place, it is called as the Lohit River. You can see this river has to be tamed. A dam has to be constructed here. You can see what is the challenge we have as an engineer or as a geologist for the national building. See, these are the near Badrinath. You can see avalanche. The glaciers coming and blocking the river. If it is near your dam site, then it's gone. So like that, I'll show you a small animated clip. Sorry. Animation. Oh, sorry, it is not working. Yeah. You will be able to see this animation. I have taken it from YouTube only. It's about Glof, glacial lake outburst. No, here you see. Hello.
You share the video, sir. You share the video.
Yeah, I'll share the video. I want to explain. See, this is a river. Say Himalayas, or it could be anywhere in the world. This
Sir,
is
video is not seen here. Video is not seen here.
oh, it is not seen, huh?
Yes, sir. Yes. You just click on the video and you show that. You minimize the PowerPoint now and you can see the video.
Okay. Now you are able to see.
No, sir.
Again, I have to do share screen.
No. You already scan is share. Your screen is shared. You just minimize the PowerPoint
Okay.
so that
Okay.
the backside it will be seen. I think.
It is seen now.
No, not sir. No, it's not seen. Maybe your network connection doesn't permit to show the videos.
Okay.
The huge file.
It is not shown now.
Yeah. It's not seen so far.
Okay.
And you can give the link in the
Okay.
slides.
Okay. So now it is not showing anyway.
You can start for the next slide, sir. From next slide.
Yeah, I'll go to the next slide. So these are the problems. I told you. I just wanted to show how a lake.
Gautam, sir?
Yes.
Hello.
Yeah.
Yes,
Principal is in the online, sir.
Okay. Yes, sir. Yes, sir. So good morning, sir. Sir,
hello.
Good morning. Yes, sir. Please continue, sir.
So now you can see an young geologist crossing the river. How he will be crossing. Just I want to show to tell you that these are the challenges which we are having. We have to so students should take care of this. Some audio disturbance is there.
No, sir, because from your YouTube channel, sir. You once you open that animation, no?
Yeah.
That is disturbing. You just close that. You minimize that. Yeah. Minimize that.
No, not this, sir. No, not this. You close the YouTube, which is playing now. Kannan, sir.
Yes, sir.
The noise is stopped. You can continue now. Another 2-3 minutes because principal is waiting.
Okay. So
Yes,
over. Sir.
Yes.
My this thing is over. I have completed.
You just complete formally. Just say.
Yeah. See, I was talking about the various aspects of engineering geology, right from the initial stage of conception to commissioning and then post-construction commissioning. And I just wanted to tell our young geologists that it is a challenging job and we should go and work in remote areas and we have to take work for the nation building. That is my thing. And I thank all of you for your patient hearing and thank you, sir.
Thank you, sir.
Thank you, sir. Kannan, sir. Thank you for your attention. Sorry, sir. Thank you for your presentation. I'm sorry. I request our principal to switch on the video and audio. Sir, good morning, sir. Sir, principal, sir.
அவர் அன்மியூட் பண்ணி அவர் மியூட்ல இருக்காங்க சார். இஸ் த மியூட். ஆஸ்க் ஹிம் டு அன்மியூட் வீடியோ அண்ட் ஆடியோ சார்.
Sir, good morning. Sir, நீங்க அதான் வீடியோவையும் ஆடியோவும் ஆன் பண்ணிடுங்க சார். Yes, sir. Dear participants, principal will be joining now. If you have questions, we can ask questions after the principal's talk, and we can also discuss afterward.
Yes, sir, we can have a question answer session also now.
No, principal is going to join, sir. So after this talk, we can continue, sir.
Okay. No, I have gone through very fast because certain things I could not.
But all are visualized. No, we can see the pictures. That is very. It is directly taken to your mind.
Fine.
Sir, principal, sir. Good morning, sir. Principal sir, good morning.
சரி இப்போ ஒரு லைன்ல இல்ல சார்.
Yeah.
Phone பண்ணி பாருங்க.
Phone பண்றேன் சார். Phone பண்றேன். Sir, meanwhile, you can ask some 1 or 2 questions to the participant. Somebody. Sir, meanwhile, we can somebody can ask questions to the resource person.
Kannan sir, this is
Yes,
Kumara
sir.
Guru.
Yes, sir. Yes, sir. Welcome, sir.
Okay. Now they are making tunnel for a very long distance, like 2 kilometers, 5 kilometers, like that.
Yes, sir.
How do they make alignment? Are they the GPS or kind of a theodolite that surveys? How do they make that correct, perfect alignment to that one point to another point? The directions.
Sir, basically it is a topographical survey. It is the base requirement. Basically,
No. I'm talking about within the tunnel. Supposing our metro tunnel is there, even our Jawahar tunnel is there, and
Yes, sir.
in UK it is connecting, that tunnel is connecting between France and England, the
Yes, sir.
undersea tunnel. So how do they make the proper correct alignment?
Sir, there's a total station.
Total station only.
Yeah. Total station.
It's so accurate.
It's very accurate. Nowadays, it's more impoverished models have come.
So that do they use that GPS system also in that?
So the GPS, see, wherever the satellite signals are not there, then it is very difficult.
It's very difficult.
GPS will not work, sir.
Total stations I know, but I just wanted to know whether it is so, accurate. So it gives that.
GPS is not accurate, sir. We have tried.
I read that when that in that English channel, when that this was connected from England scientists saying hardly there was some less than a meter or some few centimeters only that connection point. Such was the accuracy.
Okay.
That's it. Thank you.
That is a total station, sir. Yes. That is a lot of model. The Leica is there. When so many companies are coming out with novel this thing.
Okay, sir. Thank you.
Kumara Guru, sir.
Yeah.
Shall I add to it what you are telling? In the tunnel survey, underground survey, the accuracy is less when up to 5 centimeters. You can say even less than 5 centimeter. If you start from A, if you end up at B, it is even less than 5 centimeter.
Okay.
I'm talking the maximum. Maximum I'm talking. Such a fantastic and wonderful technology we have got. And also
nice.
The person behind the machine is so important. And our surveyors are really wonderful, and they have 35 years of service. 30 to 35 years of service.
Thank you. Thank you, sir.
Thank you.
There is some more question you can ask. The principal is shortly will be joining. Is there any question from the audience participants?
Mr. Kannan?
Yes, sir.
I am Dr. Sridhar.
Welcome, sir.
From Waterboard. Okay. And your presentation is very well taken.
Yes, sir.
It is really good, very informative.
Yes, sir.
And my first question is, many of us do misunderstand between the geo investigations or geotechnical investigations and soil studies. Are they same or not?
Sir, basically, we are dealing with soil or rock. These are the two things, whether it is a building or any engineering structure. So it is same. See, I don't find any difference whether it is soil mechanics or rock mechanics. You have to deal with both.
No, why I am asking this question is because I have some friends from structural engineering.
Okay.
They talk about only soil. They don't talk about rock.
Yeah, because their exposure wherever their construction or doing they're maybe dealing with where you have to deal with the rock, then you have to talk about rock only. You cannot talk
No,
about
you're talking about the multi-storied buildings,
yeah,
especially in
multi-story.
Chennai.
Yeah,
It is basically an alluvial terrain.
yes.
And once we talk about the alluvial terrain and the multi-storied buildings,
Yes,
only
sir.
the soil will come into the picture
Yes, sir.
because of the foundation
Yes,
or
sir.
the foundation engineering, and
Yes, sir.
not the geotechnical investigation. Am I right or wrong?
It should be geotechnical. You are
Geotechnical.
correct. It should be geotechnical.
Everything is geotechnical only.
Everything is geotechnical. Only two
It
aspects.
is a part. It's a part.
Mr. Sridhar,
Yeah.
Mr. Sridhar, shall I answer
tell
your
me.
question? Shall I answer
Yeah,
your
please,
question?
Prabhakar, go ahead.
What is geological mapping? Geological mapping is dip, shake, attitudes, the rock formations, and the structures. Isn't it? Okay. Hello, Sridhar.
Yeah.
What is geotechnical?
Sir, line la vandirukkaru neenga sir.
What is geotechnical map?
Gautam sir, ORT அப்படின்னு வந்திருக்கு ஒரு name.
Geotechnical map is
சார் வணக்கம் சார்.
geology. Okay. I'll talk to you.
சார் லைன்ல வந்துட்டீங்களா சார்?
வந்துட்டாங்க சார்.
ஓகே சார், நீங்க வீடியோ ஆன் பண்ணிடுங்க சார். நான் எல்லாரையும்
அவர் சார் வீடியோல தான் சார் இருக்காரு. சார் விஷுவல் சார். ஆடியோ தான் சார் இல்ல சார்.
ஆடியோவும் போட்டேன்.
ஓகே சார்.
சார் குட் மார்னிங் சார்.
குட் மார்னிங் சார்.
Yeah, very good morning.
Good morning sir.
போனை கட் பண்ணிடலாம். Dear participants, dear resource persons, and our department staff, the organizing secretary, Mr. Charles, and everybody, on behalf of our department, students, staff members, and the organizing committee, I welcome Dr. O.R. Devanathan sir, who is a principal of the prestigious Presidency College, Chennai, and to this webinar valediction function. In front of principal, I'll take 2-3 minutes to read out the report of the webinar, and I request after that the principal should give say a few words about the webinar. Shall I read out the report, sir?
Yes, sir.
Thank you, sir. Good morning to one and all present here. On behalf of the students and alumni members, staff members of Department of Geology, I wholeheartedly thank our principal, Dr. O.R. Devanathan, for his support and encouragement to conduct a 5 days webinar series on geological sciences. As convener, I express my sincere gratitude to all the resource persons who have made this webinar a great success by their vast field knowledge. The very objective of organizing this webinar during the COVID-19 lockdown is to expose the students on the various branches of earth sciences and their job opportunities. Sir, there was around 440 participants all over the country, content of faculty members, senior faculty members, senior geologists from Geological Survey of India and so many agencies, postdoctoral fellows, research scholars, PG students, UG students, and there are some participants from abroad also, Nigeria, Australia, and USA. There are total number of 9 lectures has been delivered by extreme scientists who have held key position in Government of India for more than 35 years. All the resource persons are served in Government of India in highest positions, and they have served more than 35 years, sir. That is what the unique point is. And nobody is from teaching background. They are field persons. The details of lectures, I'll just give a glimpse of it. The lecture 1 and the first day started with Dr. N.P. Nathan's lecture on geological and technical evaluation of Tamil Nadu. He is a Deputy Director General.
Geology ஒரு 10 minutesல வந்துரும்.
He is a Deputy Director General retired from Geological Survey of India, Government of Mines, Ministry of Mines, Government of India. He took a complete geological tour of the southern India through his presentation and exposed the types of rock formation in this art, especially to young budding geologists. His lecture highlighted many unknown aspects in a comprehensive manner.
Yes, yes.
The next lecture was given by Dr. R. Srinivasan, again a Deputy Director General retired from Geological Survey of India, Government of India. His topic is on societal values of geomorphological studies. Dr. Srinivasan sketched out various geomorphological formation of Tamil Nadu and its changes over the time. He also triggered the younger minds of participants to pursue research with social benefits. Lecture 3 was on given by Dr. A.V. Jayagopal, Additional Director retired, Atomic Mineral Directorate, Department of Atomic Energy, Government of India, gave a talk on atomic minerals exploration in our national building. Dr. Jayagopal briefed the basics of atomic minerals and its energy sources. He justified the topic and attracted the participants through suitable maps and photographs pertaining to the atomic mineral exploration in India with certain. He also has some little limits because it is atomic thing, which is a confidential thing. Yes, without showing some confident things, he justified the talk. Next lecture was given by Sri B. Prabhakaran. He is a chief in geology, retired from Geotechnical and Engineering Division of National Hydroelectric Power Corporation, Government of India, and he spoke on geotechnical investigation of hydroelectric projects, planning and execution. Sri Prabhakaran's talk started with basic of engineering geology and traveled to various applications which he applied in the field in the construction of major hydroelectric projects. He also explained methods of drilling through a video which brought the field to our laptops. Day 3 started with a lecture of Sri P. Kumaraguru, Director retired Geological Survey of India, Government of India, delivered a lecture on fossil fuels and energy scenario of India. Sri Kumaraguru sir clearly showed various coal-bearing formation and their distribution in India. Sri Kumaraguru sir himself showed the coal reserves, huge coal reserves. He discovered during his tenure in the service. He also exposed various coal reserves of India and huge financial resources from the coal to our country through this presentation. Next lecture was given by Sri B. Kanishkan, who was a director retired from Geological Survey of India, Government of India, on the topic of geological and commercial aspects of granite. Sri Kanishkan sir clearly brought out various granites with their geological and commercial aspects. He also emphasized the role of geologists in mapping and safe exploration of various granites, which generates huge financial resources to the country. Next day 4 was started with Dr. K. Ayasami's lecture on micropaleontology is a good career choice. Dr. Ayasami was a Deputy Director General retired from Government of India, Geological Survey of India. Dr. Ayasami presentation started with introduction of various microfossils and their applications. He stressed how the subject of paleontology should be treated and it should be mainstreamed with all geological branches. Dr. Ayasami PPT is an eye-opener for young geologists as well as a retired geoscientists. The lecture 8 was given by Dr. B. Umabadi, a senior hydrogeologist, scientist D, retired from Central Groundwater Board, Government of India, under Minister of Water Resources. He delivered a lecture on managed aquifer research. Dr. Umabadi talk started with basic of hydrogeology and various methods of recharge used in the different geological setup. He also stressed success of his own research carried out in the Virudhunagar district, which was properly called as Blue Evolution. And the last lecture number 9, was given by Shri.Kannan, who's Chief Geology, retired from Geotechnical and Engineering Division, National Hydroelectric Power Corporation, the Government of India Enterprises. He spoke on engineering geological studies for large civil engineering projects. Sri Kannan talk started with basic of engineering geology and traveled to various applications he applied in the field of construction and of major civil engineering projects. He clearly explained the job profile of an engineering geologist in a complicated terrain. The topics are such the students can decide their career and the field of job openings. The students can also decide on research areas which are shown so many thrust areas in the presentations that are to be carried out through this lecture. Sir, finally, I extend our sincere thanks to all our department staff who are also part of our aggregation committee, and the principal in particular, the resource person also. Thank you one and all, sir. Now I request our principal to say a few words about the webinar.
Very good afternoon, one and all. I am really very happy that many resource persons who have given a lot of lectures here are very well present here. I could see Dr. Shri.Kannan, A.V. Jayagopal sir, Kumaraguru, our own Kumaraguru, who is doing research in our own college, and Dr. Shri Prabhakaran. So I'm very happy that generally in other seminars, once our lecture is over, we move away and we do not care to listen to other speakers. But in this case, in this webinar, that those who have given lectures have chosen to remain here and be participants till the end really makes this webinar a grand success, I feel. That should be the success I feel personally. And I congratulate Dr. Gautam and his team for organizing, when webinars are the fashion, modern day fashion, especially post-COVID scenario, he has conducted a week-long webinar wherein 9 very useful lectures have been listened to by our students. For the benefit of our students, it has been arranged, and I am really happy, and I congratulate Dr. Gautam and his team, and especially organizing secretary Shri Charles Dana. Now, I want to say a few words about our college. This is one of the grandest and the oldest institutions of India, you all might be knowing, that it has produced more than 2-3 Nobel laureates and an able laureate. These are all laurels, and this is the place where Tamil Tata Bhuvesa worked. And there are a lot of Sanskrit scholars on whom various institutions have been established. They have also been part of this prestigious Presidency College. When we say prestigious Presidency College, it is just not for rhyme, alliteration, etc. It is really prestigious. One has to have the feel if he enters the portals of that college. Now, you may be thinking that we are standing on the past laurels, but I would like you all to know that in arts and science category of 1819, our college stood at 3rd position, and now it is at 5th position, ranked 5th at the All India level. And the first 4 positions have been carried by the arts and science colleges of Delhi. Now, which means this is the best arts and science college that the state or South India has now produced. Now, what I want to stress is, in such a great grand college, the students of geology who are studying here should really feel blessed, because they are studying in a department which is as old as the college itself. Now, this department of geology was the first to be such a department in the whole of South Asia, and it really is a great pride for us. But it has successfully produced a lot of able minds who do grand researches with regard to geology and come out with grander results. Really makes us feel proud. I hope that this webinar, wherein 9 very precious matters have been discussed, should have been a great help for our students. It is just not for widening their knowledge on geology. I understand from the report of Dr. Gautam that it is also an eye-opener for the students to choose their career in geology. So I really congratulate Dr. Gautam and his team of geology professors in our college, Dr. Charles Dana for organizing this, and all those resource persons who have given this, who have given their lectures, their peace of mind to this brilliant set of students here. And really, I congratulate and thank all those who have chosen to remain till the end, at least on this valediction day. So I thank all the resource persons, congratulate the team of geology professors for organizing and arranging this webinar. And all those participants, I really know that you have been immensely benefited. I thank you all. Thank you for the opportunity, Dr. Gautam. And I really thank from the most part of my heart for all those resource persons. Thank you. Thank you all. I hope that this is a grand success. Thank you.
Thank you. Thank you so much, sir. In your busy schedule, you are now waiting for another webinar to start. Thank you so much for joining us and wishing us this webinar to be a success one. Thank you so much. And let us, sir, shall I start with the questions, sir? So there
Yes,
are some
sir.
questions.
Yeah, you can. But I would personally would like to grant me permission to leave the meeting because I have to go for botany meeting. Thank you all. Thank you.
Thank you so much.
Thank you.
Thank you, sir.
Yeah.
Thank you. Thank you for our respected principal. And I request participants to shoot the questions to the resource person. So few questions because already we are late. One or two questions we can ask to the resource person. Yes, sir.
Gautam, sir.
Yes, sir. Yes, sir. Yes, sir.
I have got Kannan, sir.
Kannan, sir.
Hello.
Kannan, sir.
Welcome, sir.
Yeah, that's wonderful, sir.
Thank you. Thank you, sir. Thank you.
Actually, you are talking about.
Yes, sir. Actually, there was a time fixed, 11 o'clock. I had to complete, so I had to rush through literally.
No, yeah.
Sorry, sir. Kannan, sir. The principal told me that he's having another meeting, so I requested you. That's why morning I requested you.
Yes, sir. I appreciate it, sir. I appreciate it. It was a must. I can
Anyway,
understand.
you have covered the most aspect of it.
Everything
Only
you have
thing,
covered.
if you have shown that video also, it would have been a very nice thing.
It was an
we'll send the
animation.
link. We'll see that video. That's all.
It will be never will be 100%. It will be always be 99%.
Anyway, it was a very wonderful lecture and really useful to everyone.
Hello, sir.
Yeah, Kannan, sir.
Yes, sir.
Yeah. See, you after your construction, everything is over.
Yes,
you are talking about the after positions also. See, we have been. We know that your radioisotopes.
Yes, sir.
Radioisotopes are used to locate the faults or where the leakage and all.
Yes,
so, do we use anywhere, or what's your opinion about it? How successful it is?
Sir, actually, we have not used it, but technically, yes, of course, we have discussed in many meetings and other things. Especially, the radioisotopes are very, very useful in finding out the source of groundwater in underground works. So, from where the water is coming. See, in a tunnel, the Himalayas, the biggest problem is groundwater. So, the radioisotopes will guide you from where is the water source. So, but we were only discussing, we have not used it anyway.
No, that is about the groundwater. Even the leakages where the weak zones are there can also be located with the use of radioisotopes.
I mean, I have no knowledge on that.
It's okay. Thank you.
Hello, sir. I have one question.
Yes, sir.
Sir, how do you deal with the hydrostatic pressure that builds up in the dams? Usually that could cause seismic tremors later. Right?
Adityan,
yes,
you
sir.
can switch on your video also. Video, no problem. Show your face.
Okay. Yes, sir. 1 second. Hello, sir. Am I visible now?
Yeah, clear.
Sir, so I was wondering, how do we deal with this hydrostatic pressure that builds up in the dam? I mean, post-construction, usually the faults that are below the dam, they sometimes get activated and there are small tremors around the dam. So how do you usually deal with this, sir? Kannan, sir.
Actually, this is called as RIS, that is reservoir induced seismicity. So even the large water body, water is impounded, then the waves are created, and because of these waves, this earthquake is triggered like that. Koyna Dam is every time talked about the earthquakes near Koyna Dam. That is because of RIS. But I tell you, it is debatable issue. It's a debatable issue. Still, nobody has got a very data to support whether the RIS is really exists or not. We don't know, but it could be. But what is the scale of that such activity? If a seismic activity is there, what will be the scale of such activity? A natural earthquake, how much energy it can produce, and then a reservoir induced seismicity, because of that, how much energy will be produced. What ultimately, what we are important is whether our dam structure is safe or not. If a particular scale of intensity of earthquake comes, what the dam I have designed, whether it is it can withstand that much of earthquake. So we have a seismic zoning map of India, and then based on that, we interpret this much scale in this particular area, earthquake can come. Then accordingly, design parameter input has been taken, and then the project is designed to withstand to that extent of earthquake. But if it goes beyond that, what will happen? Yes, nobody has any answer. There could be a crack in the dam. There could be a collapse in the dam, that we don't know. But at least with the present knowledge, whatever we can do in the design of the dam, the location of the dam. See, for example, Theri Dam. Theri Dam in Himalayas, it is located in zone 5. Highest, I mean, earthquake to the extent of 8.5 can occur there. That is very disastrous, catastrophic earthquake it will be. So now they have not constructed a concrete gravity dam. There they have constructed a rockfill dam. So rockfill dam is more flexible than a. So accordingly you have to decide. But when your question is about RIS, regarding RIS, I tell you, I don't know how much energy it can produce, how much earthquake it can trigger in that particular area. It requires a lot of data, a lot of studies, and then we don't have many examples to prove whether this is right or that is right. That is a real situation.
Thank you, sir.
Adityan. So I request the participants to ask questions, because the people, resource persons are.
Sir, Gautam sir, I take some questions from YouTube on chatting, sir.
Yes, sir.
Sir, there is a question. Hello, Kannan sir.
Yes, sir. Yes, sir. Welcome, sir.
Sir, is there any geotechnical structure for harvest sea energy, waves and tides?
Sir, yeah, definitely. In Kutch Basin, they have done some preliminary studies. There are, during a day, there is a high tide and low tide. High tide and low tide is. So some structures can be built along the shores. But it cannot, every shoreline will not give you this energy. But there are at Kutch they have done some studies, but nothing has been concrete now so far. Okay. But in France and all, they have made tidal energy. They are extracting. That is there. But in India, it is not. Okay. But there are scope. There are scope.
Okay. Sir, next question. What are the precautions to be taken care while constructing dam on sedimentary rocks as basements, and the reasons for failure?
Yes, sir. Sedimentary rock, only thing is we have to do the investigation and find out whether there are any fissures or whether there are any shear zones, where there are crushed zones, soft nature of the rock like that. Then what we do is, the precaution is, we do inject grouting. We do consolidation grouting of that material. So when anything cement is injected, and it goes and fills in all the areas, and then it takes care of it. That is the thing. Mainly grouting is done, a proper curtain grouting, and then consolidation grouting is done in the dam site. Whether it is sedimentary rock or it is an hard rock, it's no matter. So long it can, my footing is safe.
Okay.
So that is how it is managed.
Okay, so one big question I'll read out, sir. One big question.
Yes, sir.
I'll just read out. If we are about to construct a tunnel in a
Yes, sir.
fold and a soft rock is repeating,
Yes, sir.
what is advisable, sir? Same question. Is there any engineering construction to support the tunnel or not to construct the tunnel and find an alternative? This is a question. I'll read out again.
Yes, sir.
If we are about to construct a tunnel in a fold or a soft rock is repeating, what is our advisable, sir? What is our advice?
Yes, sir. Yes, sir. Yes, sir. It is a folded strata, where you have got a repeated soft rock. So the dealing a soft rock is a little difficult in a tunnel, but you have to see what is the thickness of that soft rock. If the thickness of soft rock is going to be only 2 meter, 3 meter, you can still manage. Even if it repeats, we can always manage it. But if it is going to be 10 meter, 15 meter, 20 meter, you are going to have only a soft material, and then it will continuously collapse, and then your production time will be lost. You will be seeing a lot of time and money is wasted on that soft rock. So the better to have a better location. In advance, if you know it, I will always prefer a better alignment than going for a 20 meter, 30 meter in a soft material where I can have a better, but it is not always possible. You cannot have a metro tunnel you are making, or you are making a railway tunnel. You have to the two endpoints, you know it. So you will always try to connect it to a short route. You cannot have a D route. You cannot make a circular route just because your geology does not permit it. It's not possible. Nobody will agree it. You have to, the geology, you have to support it. If it is a soft, see, this is the only alternative available, a cost-effective solution. Then you have to evolve a methodology for treating that soft rock. That is how we have to approach it. See, everything, every site is a unique, every project is a unique, and every solution should be unique, and it will be just because your previous knowledge you cannot apply in another project, because every site condition varies.
Okay.
That's how it is.
Sanchari Banerjee, you can ask question by showing your audio and video.
Sir, one more question from YouTube, sir.
Yes, sir. Yes. I have seen it. Now Banerjee can ask question. Okay. Banerjee?
Yes, sir. Yes, sir.
You switch on your audio, right? Yeah.
Good morning, sir. Sir, I would just like to ask you that we saw a slide in which the water seepage was there on left and right side after the construction of the dam. Sir, I just wanted to know that is there any way of preventing that after the construction? Means how can it be stopped, or to carry on the work there, how can it be stopped?
Yeah. I come to that. I'll come to. I understood your question.
Yes,
sir. It was basically a tunnel. Okay.
Yes, sir.
It was a tunnel where there is a seepage. The tunnel, inside the tunnel, water will be there. Even the seepage will be there.
Yes, here, sir. Because
on the right side, on the left side, I only shown two locations from where this thing. So now, first of all, to identify the location of seepage. It is very difficult when one tunnel is filled, you will not know from where water is coming. It may be dripping from the top, it may be coming from the bottom, or it may be coming from the walls. So there are different sources of water. See, that's what I told you at that time. If it is an perched water, immediately after you open it, you puncture it, then it will flow continuously with a particular speed. It will flow for few days. Say 2 days, 3 days, 4 days, depending upon which there is the capacity, the reservoir inside the water. But if it has got a permanent source, it is a huge hydraulic head behind this tunnel. See, the solution is, first of all, how we treat. If there is a groundwater problem, because we have experienced in many projects, how we treat. So now, first of all, you should have a drainage inside the tunnel. What is the quantity of water? A geologist has to see how much water is flowing in the flowing from the seepage, and then for that a proper drainage has to be made and the tunnel gradient, sometimes it will not help you. So you have to have a small sump inside the tunnel, and then from there you have to pump out, because it may be grading in tunnel or it may be grading up tunnel. Depending upon the gravity, you have to use the water pump or you do a gravity drainage. That is one thing. Is first thing is you drainage. Second thing is the drainage is not possible because there is a flushing of water is coming, and with a lot of muck and material and other things, you will be stuck up, and 1 month, 2 months, your work is wasted. So much of water is ground, you are not able to. So now we have to find out the source. The geologist has to survey that complete area. He will walk around the area. He will find out the source from where it is coming. Then there are some discharge wells can be made, and then that water from outside the tunnel, it can be pumped out. So these are some of the techniques you have to apply, and then you do the grouting, continuous grouting of the bottom of the ceiling and the walls. You do continuous grouting and then seal the fissures and from where the water is coming. So that's how it is dealt, and every time it has to be so the solution has to be adopted.
Thank you.
I am Dr. Sridhar. Hello.
Yes, sir. Please continue, sir. Voice is clear, sir. You can ask. Sridhar, sir. You can switch on your audio video. Sridhar, sir. Sir, Kannan, sir.
Yes, sir. Yes, sir.
Another question.
Yes, sir.
I'll just read out the question. The best method to determine the spacing of discontinuity on digital 3D model of a rock slab. What is the method used, sir?
It is for
3D modeling. 3D modeling.
3D modeling. What we use is the DIPS program. DIPS program is there. That can be version 5. I think I have used up to version 5. Nowadays, I don't know. Maybe 5-6 years. Now I don't know what version is there. Latest version, DIPS program for the statistical analysis, stereographic projection of the joints, attitudes, joints, and then bedding or foliation. So that you can do it. And then for the tunnel inside study, there are various programs like Unwedge. So these are all very useful. This one is compatible to the other. You do the analysis for DIPS and then take it to Unwedge and then design your support system for the tunnels. These are all basically for tunnels.
Yes. Dr. Sridhar?
Yeah. Sir?
Hello.
Yes, sir.
I am again coming, sir.
Sure, sir.
I am a retired hydrogeologist from Rted. I am Dr. Sridhar.
Yes, sir.
So
yes,
then
sir.
after retiring from Rted,
sir, I think I have met you when I was in PWD groundwater, sir, Chepak.
maybe, sir. I am not exactly sure. But then I joined this Metro Rail, sir, Chennai Metro Rail for geotechnical investigations.
Yes, sir. Yes, sir.
So I have been taking up this investigations work for the past 2.5 years.
Okay, sir.
My basic questions are, see, suppose we are doing seismic survey.
Yes, sir.
Whether it should be done in the orthogonal or linear array. So this is what certain doubts they used to ask me and I used to clear them. But what is this linear array and orthogonal array? I told them to go for L shape, orthogonal array.
Yes, sir.
Am I right or wrong, sir?
Sir, normally what we have done so far, what I have done is a linear array, sir.
Okay.
Because we do line drilling in a particular this thing, and then say about 2-3 drill holes in one linear line, and then we do the geophysical survey and correlate the borehole data with the geophysical data, and we are able to see what is the lithology below the surface. So this is how we are done. Orthogonal, we are not done. But sir, one more thing is there. If we required in orthogonal in other direction, we always prefer to lay another profile. It is always done another profile across to the one profile. What we do is we take 3 profiles in one linear array and then across 1 or 2 arrays, and to know the complete, you will get a fence diagram type subsurface lithological structure you will get it. That's how it is done.
One more question, sir. Is there any criteria fixed by NHPC for van shear test?
No, sir. Actually, NHPC doesn't do any testing, sir.
Okay.
So normally the testings are done through laboratory like CSMRS is there, CMRI Dhanbad is there, and there are private agencies are there. When she test that Roorkee geotechnical this thing that they are doing it, Roorkee University, they are doing it. We employ them, sir.
And even drilling you're outsourcing, sir, how it is?
Drilling once upon a time, when I joined NHPC, we had our in-house drilling team. But slowly we have withdrawn that activity, then we outsource it.
No, because I'm talking about this saturated, unsaturated soils, SPT values and all those things.
No, sir. All these things done by outsourcer.
Outsource. Thank you, sir. Thank you very much.
Yes.
Thank you, sir.
Excuse me, Gautam.
I want to give a chance to students. Give a chance to student, please.
Yes, sir.
No, I am giving you the explanation for the seepage.
Yes, sir. Yes, sir.
I'm adding to that.
Yes, sir.
Because what this the question was the seepage problem in the hydroelectric projects. The hydroelectric projects have three components: dam, tunnel, and power house. Then we have got facilities and observational points, piezometers, and the observational grips in the dam body itself, where we daily, periodically, we inspect the dam observational points in the grip, and we see if there is any seepage, and we notice, as well as in the powerhouse area also, we have the observation points. These observations will indicate what is the quantity of seepage, and for the tunnel, the seepage is in the outwards. So we calculate according to the observations, and then we decide. Even if the seepage is more in the tunnel, we even shut down the project, and we drain out the entire tunnel, and we inspect each centimeter of the tunnel, and we observe and identify the location, what is the purpose, what is the where it has got the leakage, and the treatment is the grouting, and also main is grouting. That's all.
Thank you, sir. Thank you so much. Sir, we already, time is 11:50. So we'll conclude this session because I'll put all the questions for what we are receiving to you, and you can answer it by email so that I can send to the participant. So we are coming to the end of this webinar with your session, beautiful session, and on behalf of our department, principal, students, I thank all the resource persons who actively participated, and actually who are there in all the presentations. I could see all the resource persons were in all the presentations. That is a good sign of sharing knowledge, because from your point of view, one specialization, you can ask the questions to another specialization, which is a more benefit to us. So, and as I request in the beginning of the presentation, you should support by giving lectures repeatedly, so that our students will be benefited and your knowledge should be transferred. Knowledge will be transferred to the young minds, so that in this critical stage of we are facing a severe pandemic stage, students should not feel that they are out of college. They should be very much in touch with the subject. I request all the resource persons to kindly accept our request and give lectures to the students. And I would heartily thank all the resource persons for a valuable presentation and time you are given to us. And I also request kindly to share the presentations to organizing secretary, so that it will be shared to the participants also. Those who are not able to listen through because of some audio or video problem, they can read out the presentation and they can understand. And that is the idea. And I should appreciate Mr. Charles, because he's the one who has made our idea to become as a live program.
Thank you, sir.
We have so many ideas. We are having so many thinking in our mind, but it should be brought to, it should be executed, and it should be executed, and it was neatly executed by Charles. And I think all the resource person will accept this.
3 cheers to Charles.
Yes.
Thank you.
Or two thumbs to Charles.
Thank you so much, Charles. Thank you, Charles.
And a big hand also.
Yes. Charles, this is not the end. We are going to start individual lectures.
Beginning.
It is going to start individual lectures to our students.
Yes, sir.
Now we will focus on, in between we can also start a 1-day program for like this general participants also.
Yes, sir.
And Nathan sir, Nathan sir, I'll just say one sorry to you, because Nathan sir want to share something about the mineral exploration and his thing. I have replied him that it will be given as a separate lecture some other day. I am very sorry, sir, because
can you give me
I don't know the
1 minute? Can
yes,
you
sir,
give
yes,
me 1 minute?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Just yes. At the outset, I want to thank Dr. Gautam and Mr. Charles for arranging this wonderful webinar, because I have been attending simultaneously the Salem webinar also, the college, but there it is only one lecture per day or alternate days or like that. But here it is a continuous marathon session. I arranged all 5 days with a full attendance. This is something that shows the success of this webinar, organized very nicely by Dr. Gautam and ably supported by our friend Dr. Charles.
Thank you, sir.
The first day we gave the geology, we were discussing structure and other things. Its applications, I think now students will be appreciating when Dr. Kannan's lecture was delivered today. So what is the relevance of the structure in any of your projects, especially the engineering projects? In geology, we can tell there is a shear zone, there is a fault, and you can get away with it. But in engineering project, everything counts, because human lives are involved. Where people who are working in the tunnel are to be safe. So all our interpretations on structural, geological, everything has to be done in a meticulous way. So the implication of our geological observation in the field, how it has got the relevance in the engineering geology, or even in the dimension stone, in any exploration for that matter, that I think students must be now quite appreciate the connection between these different lectures that has been arranged here.
Yes.
There are different opportunities, we are told. Mineral exploration is one of the opportunities where we have to augment our resources. In that way, we have just we have made a humble beginning. We have formed an academy, mineral exploration academy, especially to disable screen sharing. Dana sir, you can just one slide only.
Yes, sir.
You can just allow me to share.
Allowed, sir. Allowed, sir. Yeah. You can share now.
Now I will be just giving this particular slide only for the benefit of those who are interested in getting into the mineral exploration field. So for them, you can just visit the site, the mineral exploration academy.com. Here you will get all the course material, classroom lectures, and then discussion videos. The videos are recorded from the industry experts. Charles Devnesh, who is the mastermind in the gold exploration in the entire country. Then Biplab Chattopadhyaya, who is again the Rio Tinto's gold, the diamond man. Likewise, PGE, RE, all these experts' lectures are now recorded and then put it in this academy video, YouTube. You can visit this, and then this is a free of cost. For kind information, this entire material is free of cost. You need not have to pay anything. You can just access a site and then get all the information for the benefit of the student community, especially. This is a great service being rendered by Dr. Amit Tripathi, my close friend, who is the coordinator of this academy. This just I wanted to share for the benefit of the younger generation. Thank you.
Thank you, sir. Thank you so much. Thank you, one and all, for excellent webinar program. And I just one thing I want to say, because in this webinar is started with the resource person who doesn't have any. They are not taught so far in the colleges. They might have visited as a special lectures and all like that. But I thought that they are not teachers, they are field workers. Actually, they are actually in the field, they are working. Including me as a teacher, I used to say that we read textbook which was written 5 years before, 4 years before. But the purpose of calling you is what is in the current status in the field. You will explain. That is what the idea we have brought you all here, and it was a great success, and we have successfully transferred the knowledge, your knowledge, to young minds. In that way, we are very happy, and also a support. And I also give my thanks to my department staff members, college staff members, and our esteemed alumni. And alumni is my our backbone. So we are actually starting all the work on the basis of the alumni. I thank the Ayasami sir, the president of Alumni Association, and the General Secretary Sri Hari Arian sir, for allowing us to go ahead with this thing. And also support, I thank all the geologists, senior geologists who have came forward to support us by the means of both means of technical and financial. So my thanks goes to everyone. And with this, I will end the session. As usual, the session
with virtual tea. With virtual tea.
With virtual tea. The webinar is kick-started by Charles, and it will be ended by Charles. Charles, you can close now. Thank you so much.
Thank you, everyone. Thank
Bye.
you.
Thank you, everyone.
Thank you. Thank you, Charles.
It was a nice Corona meeting. Nice Corona meeting. And,
many more webinars and lectures.
Thank you.
Huh?
Thank you,
Now,
Charles.
Presidency College in the limelight.
Yes.
so
But
everyone has
with
got
your
some
leadership
energy now.
Nathan's leadership.
Gautam
No.
and Dr. Charles.
Nathan's leadership.
No, sir. It is Dr. Gautam's leadership. We are only soldiers.
Yes, sir. Yes. Only Gautam sir tell me I am.
Okay.
It's good. It's good. We are satisfied.
Okay.
Sir, last 5 days we got a new
Charles.
energy,
Yes,
sir.
sir.
We are very we got new energy now.
Yeah.
Listening and all. It's a very cheerful moment, and it was a very nice session.
Okay, sir. Thank you.
Hey,
Thank you,
especially
Charles.
personally, I thank Dr. Kannan sir. Yes, such a wonderful work, really, sir. I heads up to you. Yes, your experience speaks fantastic. Because I have been moving with our EG people, but the Himalayan geology EG projects are really challenging.
Yes,
When
sir.
you
Our
say
people,
that,
Jalote, PN Mishra, and all those people, they used to tell.
sir,
Even Chukka
Kannan
Idol
sir,
project in Bhutan,
Kannan sir,
it used to be a very challenging one. So
one
that speaks
question.
the volume of energy, I mean, in the experience that he has gained in this.
Yes, sir.
Thank you. Thank you so
I
much.
Kannan
thank
sir,
my principal and my
Kannan sir,
Dr.
had you
Gautam
been to
sir
Galawan
who
area?
give this opportunity to make
Kannan sir, had you been to Galwan area?
Kalpan, sir.
No. Where that LAC problem is going on between China and
There
our
is no
country.
project.
No, sir. I have gone to
Pangong.
Tawang in Arunachal Pradesh.
Arunachal, yes.
That is Tawang was the place where in 1962 war China came inside.
Yeah.
Exactly.
That area they have even today they marked, but they withdrawn that this thing to 1962. This side I have not gone, sir. Like Leh Ladakh, I have not gone.
I thank Gautam sir for giving this opportunity. I am as a organizing secretary. I thank our principal to make this successful program. I thank every resource person and participants and alumni and my colleagues and my friends. Thank you all. Now I have to close the session. We'll meet soon. Thank you, sir.
Thank you very much.
Very good.
Thank you all. Thank you.
Thank you, Gautam.
Thank you, sir.
Thank you, Gautam.
Thank you, sir. Thank you.
Thank you.